unless there is an emergency. Yeah. So where are we? Talking about energy technologies, and then in that we were talking about the nuclear energy technology. Significant because we know that we are still using it, we are developing it. So it is not just one technology, but the concept is simple, but the applications are different. As usual with most of the source of energy. So concepts are important in this because a lot of concepts are there which will go into physics. Sometimes it is called as nuclear physics, but atomic physics, nuclear physics are kind of school things. You don't have to really worry about those fundamental things. And we have a new addition also, that is particle physics, that quantum reality. But the questions will be based on all those concepts, and important things would be what? Your applications. Applications are numerous, and one such is for energy production, electricity generation, and another one is weapons. So in both cases we are applying these. So for example, nuclear weapons are currently trending. Some people threaten others in the name of nuclear weapons. Some people fear others because they have nuclear weapons. And entire world is calculating who is more powerful than whom and who has how much nuclear power, this, that and all. But for peaceful purposes, there is one more application. Apart from that, there are multiple small scale applications of nuclear technology. Small scale means what? For example, smoke detectors use radioactive isotopes. In medical science, both for diagnosis as well as treatment, we use radioactive isotopes. Not only for these things, but propelling engines or supplying electricity for engines and maybe in the ships or submarines or spacecrafts or for example, Voyager or Horizon. You must have seen Horizon has reached Pluto. NASA has sent Horizon, which has reached Pluto, and Voyager has left solar system and still is working. And these two extraterrestrial, that is outer space crafts were powered by radioactive isotopes, which have reached Pluto. Horizon has reached Pluto, and Voyager exited solar system, has entered the other solar systems of our Milky Way, that is galaxy. You can imagine how much of electricity and for how long it would be generated, and that is nuclear powered spacecraft. So we are looking at a very big picture in terms of applications. They are numerous, but concepts are limited. So focus on these concepts so that if you read any article in the newspaper, it makes some sense to you. How is it possible? At least that is the only difference between educated and uneducated. Many people can read newspaper, if you go to Kerala or Mizoram, 99% of the people are literate. Even you go to Manipur or even many places, they read English properly. They are English literates. They read newspaper. But for how many it makes sense what is present in the article? For how many it makes sense? Not too many. You have to understand this. It should make sense to you. For it to make sense, you got to have a concept strong. Otherwise, it becomes just a news item. And you don't get questions on news items in UPSC Civil Service exam. Not on news item. But why it is so and why it is not. What it is not. You will understand this. Because statement based questions would test the knowledge of concepts and applications in relation to each other, not just about news item. You will understand this. The questions are not based on facts, date and year. No, they are not based on date and year. And they are not based on the headline of a news item. Never ever. That is why we, request people don't just read newspaper, because many people can read newspaper. Studying it and ensuring that it makes sense. and helps you answer few questions in the exam. In that way, you should study it. Otherwise, many people read newspaper, but still, it doesn't help to many. We will see how it is. Yes. So, nuclear energy technology. So, the natural questions would be, and from where energy comes in the nucleus, and what is the nucleus, and in which form do we have energy in the nucleus, and how do we take it out, becomes the core concept of nuclear energy technology. That would be our focus here. Simple it is. Please remember, we know that there are many fundamental forces in the universe which are responsible for transfer of matter and energy from one place to another place, from one type to another type, from one time to another time. Please remember, there are multiple dimensions in the universe. Time dimension, place dimension, temporospatial we call it as. Time dimension, space dimension in general, and form dimension. Which form? For example, in the previous session you have seen allotrope. What is an allotrope?
Same element,
various forms. Same element, various forms. So, form dimension. So, time dimension, from one time to another time. Place, that is space dimension, from one place to another place. For example, you are receiving energy from sun to earth. That is a place dimension. Please understand this. At the same time, during daytime you have light, during night time you don't. That means a time dimension. Both are we experience every day, yes and no. Form dimension. In some places, sunlight is direct. In some places on the earth, sunlight is not direct. Form dimension. At the same time, are you able to understand this? So, there are various dimensions through which matter and energy change. You have to understand this. So, we know that a universe is made of two things: matter, energy. The entire universe, known universe. Okay, we know little, fine. So, entire known universe is made of two things. Of course, we added one more. What is that? We added one more dimension with which universe is made. Time dimension. Excellent. We added that. That is a new addition because not many people understand it. Not many people understand time dimension. Do you think universe follows time dimension or it has some clock? For our understanding, we added it. Do you think birds, animals, plants, they have a clock to follow? It's a human thing. Please understand this. We created it to understand what's happening around better and for documentation purposes, for analysis purposes, for research purposes. We just divided everything into time frame because in engineering and mathematics, maybe some of you are engineers or mathematicians. There is one principle that if you can convert anything into numbers, you are simplifying it. That's a principle behind mathematics and engineering, isn't it? Hello? So, quantification, you know that. CSAT, you have it, yes and no. Quantitative abilities. If you can convert anything into numbers, that is simplification. For us, non-human creatures don't understand numbers. You understand this? They don't have such, interpretation of converting something into numbers. Time, number, matter, number, energy, number. We convert everything into numbers. Human beings, numbers. Yes or no? Your worth, your value, numbers. Bank account, Yes or no? Marks, numbers. Whether you are eligible to become a civil servant or not, rank, numbers. Good or bad, numbers. Capable or not, numbers. Everything, it's a number game. Usually. Yes. Okay. So, we are not talking about numerology here though, but still, lucky number, kind of stuff people, interpret. Getting back here, fundamental forces which operate between matter and energy, conversion, interconversions, these things, we have certain forces here. So we have one such is a nuclear force. But nuclear force exists in two different forms. We'll talk about that. One. Second is what? Please understand, we have a lot of other things here. So apart from nuclear force, we have something called as what? Electromagnetic force. And we also can have, what is that here? Universal. That means fundamental force in the universe. So in nuclear force, we have something called as strong nuclear force, and of course little different here, weak nuclear force. You will understand this. So these forces are responsible for whatever happens between matter and matter, matter and energy, energy and energy. You will understand this. And coincidentally, nuclear force is considered as strongest among all these. So we are going to talk about that. And gravitational force is considered as weakest when you are talking about entire universe. But on the earth, gravitation is pretty strong. Try jumping from the top of a building. You would understand only upon reaching the ground. Yes or no? Initially when you jump, you will feel that you are flying. Initially, for a few seconds. The moment you touch down, hey, gravity works. Suddenly you will become educated, enlightenment. You would understand how strong is gravity, yes or no? When you fall from a bike, when you jump, when your phone falls on the ground and shatters into pieces. Okay, maybe cardiac arrest and I can help you, but still, yeah, that's a different story. But you would understand gravity, yes or no? Okay, great. But when the dimension is at the scale of universe, gravitational force becomes weakest fundamental, because gravity is not same. Why do you think Earth has gravity? You can speak. There is not library. Oh, you will speak only in library or what? No, we do everything in opposite direction. That's how your brain works, If we say, eat this is good, you will say, tell me what's the worst. We'll eat it first. You want to test your life, by doing worst things first and then entering hospital. Assuming that doctor and hospital will save your life. Sorry for disappointing you. Many dead bodies come out of hospitals. Don't depend. We have delivered many bodies from hospital. They entered alive into hospital, but went in a different form. While you are awake, alive, aware, try to be healthy. Hospital is not a place to become healthy. That's a place to die for many. Okay, anyways, morning, what this fellow is talking. Would be your next thought, yes or no? Hey, a long time, busy, huh? I was also, yeah, kind of. So, in general, what is that we are looking at here? We said nuclear force is strong fundamental force or strongest among these three. Now, how do we get it? Please remember, nuclear means, in general, you have to talk about what? Very basic concepts. Universe, matter is made of atoms. Atom is structural and functional unit of matter. Universe is made of matter. Atom. What do you call atom in Telugu? That's the problem. Thanks to British, we have a language problem. Not with our native language or mother tongue, because of them. And you say they are bad. They were bad. Look at yourself. How good are you? So is the world around. Your mother tongue, Telugu. Because of this education system, you learned English. Now you forgot Telugu and you blame British. You did everything and you blame others. That's how a human life is most of the times. In most scenarios. Remember this before pointing out someone or judging someone else. Be very cautious. You get it? You and you alone are responsible for everything, whatever happens with your life. You alone. And this attitude is important, leadership quality once you become a civil servant, you know. Because these will give you accountability and responsibility. Of course, little bit of empathy. Nobody wants your sympathy. Empathy. Hope you know the difference. Anyways, we have GS4, we'll talk about that. Get it? Okay. Atom. Atom means what? Anu. What? You said, right? Yeah. I saw the answer on your face. Okay. Subatomic particle, Paramanu. Electron, proton, that is different. Paramanu movie is there. Hindi movie, yes, na? First of all, I know very little movies. Don't tell that you don't even know that also. Paramanu. Anyways, don't worry about it. So, okay. Atom. Universe, matter is made of atoms. And usually, every atom will have a nucleus. Usually, atom contains what? Usually. Electron. So, this is nucleus. This is atom. This is what? Electron. So, electron is negatively charged, usually negatively charged outside the nucleus. You have to understand this. If matter, you know that state of matter? Matter exists in how many states? Yes, please. Fifth state. First is. Second is, we know that. What is that? Third is. Fourth is. So Bose-Einstein condensate, we know that. Plasma is what? Ionic state. So only in plasma, that means very high energy, state of matter at very high energy, electrons are present outside the atom. Only, just remember these are concepts, they don't change over time. Your application might change. Now, why it is important would be your next question. When we talk about one type of technology called as nuclear fusion, not fission, fusion, only one which is under construction now in a place called as Calderache, southern France. It started in 1985, still going on. You understand this? It's called as International Thermonuclear Experimental Reactor, which uses a magnetic confinement technology in which matter is in plasma state. Hydrogen ions are in plasma state. Now, you should know what is plasma. Number one, you know that it is one type of state of matter. Now you know. Number two, matter would be at high energy in plasma state. Now you know these points. Another point we are adding is what? In plasma state of matter, electrons are present outside the atom. In other cases, electrons are present within, except in plasma state. That is the difference. What it means we will understand when we talk about nuclear fusion based reactor construction, we will talk. But until then, fundamental concept is what? Plasma state, electrons are outside. Okay, what it means. Okay, so basic atom, and electron is subatomic particle, proton is subatomic particle, neutron is subatomic particle. Subatomic particle. Subatomic particle we are looking at. Usually there are three: electron, proton, proton. Electron is usually negatively charged. Please remember, charge is important here. This indicates its orientation. Electromagnetic orientation, usually. So, electron is negatively charged, and inside the nucleus, proton is positively charged. And please remember that because proton and neutron are present within the nucleus, these proton and neutron are also called as what? Also called as? We mentioned about this earlier. Yes or no? Nucleons. You have to understand this. Nucleon number is important because it represents mass of an atom. Mass is important because you know that Einstein proposed a theory called as theory of, what is this here? Theory of mass defect. You should understand mass in multiple dimensions. So, mass of an atom plays a very important role in understanding nuclear energy and how a different mass would alter the properties of an element drastically. For example, in the previous session we mentioned that, if you remember, there is an element called as thorium with a mass of 232. 90 is atomic number, 232. But if a mass of thorium increased by 1, just 1, it becomes uranium. This element doesn't undergo nuclear fission, but this element is readily fissile. That means reactive. It produces huge amount of energy. Difference is only 1 neutron, just 1 number. Similarly, we have an element called as abundantly available in the Earth's crust, uranium-238, non-fissile, doesn't react to nuclear fission immediately. 99.7% of uranium available in the Earth's crust is available in the form of uranium-238 only, which is non-fissile. Please understand this. If the mass is increased to just 1 by 1 number, 239, it becomes what? Highly reactive, explosive, weapon grade, plutonium-239. By far, till now, the most fissile, readily fissile, most energetic radioactive material humans have ever known is plutonium-239. It undergoes only 53 cycles of fission and produces millions, billions of times of energy than conventional weapons. Hence, it is called as weapon grade, highly enriched. Difference is only 1. The 1 is the smallest number, but not least significant, rather most significant. Often it becomes the only difference. You have to understand this. Get it? Just simple things. So, mass is significant and you should know what is mass. What is mass here? Hence, mass defect. So, number of nucleons represents mass of an atom. Then usually proton number would be discussed as atomic number. See, atomic number is not very significant except in identification of the element, that's all. Because different elements have different atomic numbers. Identity of atoms, identity. For example, again I request you to have a look at periodic table. Identity of an atom is purely based on atomic number. You will understand this? So we can have any element differentiated. If not, you can have isotopes, allotropes, and you know the difference. Allotropes are various forms and isotopes are same atomic number, various masses. So proton number becomes identity. It becomes the atomic number. Very, very important. Now the problem is when number of protons increase, that means when you move into heavier atoms, that means heavier elements in general, or higher atomic number. When you look at atoms or elements with higher atomic number, that means more number of protons. Number of protons. What happens? Protons are positively charged. What happens when more protons are present near to each other? What happens? They repel each other. You know, you studied like charges repel, unlike charges attract. Yes. So protons, if they are present in large numbers within the nucleus, that means we are looking at elements with higher atomic number, where there are more number of protons. What happens here? Proton-proton repulsive force which exists for proton being positively charged. This charge is electromagnetic force, please understand this. So electromagnetic force of repulsion between protons becomes so great, often this leads to instability. But to prevent this, they need high mass. High mass. That means they need to have very high number of neutrons. Please understand this. For example, same examples we say, you take hydrogen, the lightest known element to humans, has only one proton and no neutron because atomic number is 1, mass is also 1, hence lightest. But when you move from hydrogen to helium, second, helium, atomic number is 2, but mass is 4. The moment another proton enters, there is fight. Yes or no? With whom do we fight? With another person. If another person is not there, no fight. Peace always. Yes or no? Well, not philosophically, or just kind of theoretically. The moment you interact with another person, there is a potential conflict awaiting. And your soft skills need to play a role, not to fight. Otherwise, fight is inherent, especially of the same electromagnetic energy. You may call it as competition. You may call it as envy or jealousy. Different names, same conflict. You will understand this. The moment another proton enters, helium has atomic number 2. 2 means what? 2 protons are there. Proton, fight. Hence, they need more mass. Hence, there are 2 neutrons, increasing the mass to 4. Helium has mass of 4. And you look at thorium, atomic number is 90, but mass is 232. How many neutrons are required to overcome the repulsive forces between protons? Hence, we say a statement in nuclear physics or atomic physics that higher the atomic number, more will be the mass. Now you know why. Let me add little more value to it. That, please remember, proton repulsive forces are electromagnetic in nature because charge, because they are positively charged, they repel. Electromagnetic usually. And how neutron would control it? Please remember, addition of neutron. Neutron inherently has the ability to represent energy because neutron can move with the speed of light. So we have, they have no charge, neutral charge, and negligible amount of mass at rest, but capable of moving at high speeds by absorbing energy. Please understand this. At rest, negligible mass. It is like, playing catch. You have any pen cap, you can play catch, yes or no. Slow. Like a bullet. You can play catch with a bullet also. 9mm also. Yes, catch. Because it is slow moving. Catch means slow moving. The same bullet, you load it in a pistol and then you fire. Same bullet, same innocent lovely bullet with which you played. You can catch, but for the last time. It will go through. Yes or no? Same bullet. You loved it. You played with it. You nicknamed it. What's the difference? Speed. Bike accident, 20 kilometers per hour. You will just move 100 kilometers per hour. RIP. Same bike, same you. Difference is speed. Hence people say speed kills. But we want kick. Thrill we want. Okay. Let me not play the role of a cop, a traffic cop. A traffic police. I have one friend. Whenever he talks, he'll be talking about rules. Is it enough? We also know some rules. Yes or no? Keep them with you and teach them to people who break them. We don't break them because we don't need to break them. We can live normally also without breaking. Yes or no? So, looking at repulsive force. So, to keep this repulsive force intact from destroying the atom, we need a greater force. And that force is the proton-neutron force called as nuclear force. That force which keeps the atom intact in spite of having repulsive forces existing between proton and proton trying to destroy the atom is called as nuclear force. And that is why as an atom will have more number of protons, as the atomic number increases, they need to have more number of neutrons, more mass to keep that element or atom stable and intact. You will understand this. You have seen this, yes or no? Helium has 2 proton, 2 neutron. Yes? Atomic number is 2, mass is 4. Whereas hydrogen has 1 proton. No need of any neutron. Yes or no? No need of any neutron because there is no repulsive force. Please understand this. When there is repulsive force, there is a need of nuclear force to keep the repulsive force away from destroying the atom. Please remember, entire universe works based on need. Need based, rational, need based. There is a reason for everything. Whether you know it or not, whether you accept it or not. Why hydrogen doesn't have a neutron and why helium needs one, two rather, and why thorium needs so many, and why uranium-238 needs so many. You will understand this. There is a need. What is that need here? We are looking at nuclear force to keep proton and neutron usually controls the repulsive electromagnetic force between proton and neutron, proton, and thus keeps the atom intact and stable. This is the first point you should understand, concerned with stability of an atom. Now, the same point has contradiction. What is that contradiction you are talking about? That as the atomic number exceeds 83 or little more than 80, atomic number, proton number. If it exceeds 80, usually beyond 83, usually the atom or element becomes naturally unstable. I said contradictory. You get the point here? Yes? What is the contradiction? Too much in the morning? Is it too much in the morning? Try not to overthink. Just focus on what I am saying. Easy. That means you are not focusing. As simple as that. You are focusing? Then what's the answer? Don't tell me what's the question. What's the question? What's the contradiction? The previous statement and the present statement. Yes or no? Yes, please. You want to say something? No? You don't want to say anything? Silence is not an answer to any question. By being silent, you are not answering anyone. You don't want to answer is not an option. Nota is not an option. You get it? So what's the answer? What's the contradiction here? Earlier we said that higher the number of protons, more repulsive force. To overcome that repulsive force, we need more mass, higher mass, because proton-neutron nuclear force will control the proton-proton repulsive force. Hence, higher the atomic number, greater will be mass. You said one statement. You understood that point, hopefully. If not, I can repeat, not a problem. You're processing, right? Yes? Now we are issuing another statement. Any element beyond the atomic number 80, usually 83 or more, atomic number is proton number. Large number of protons, proton-proton repulsion, yes, are naturally unstable. Excuse me. That's a contradiction. Yes or no? Why? Naturally, why? Now we have to talk about stability, instability of an atom. That's a concept again. What is responsible for stability of an atom and what is responsible for instability of an atom? Yes, because we have had questions on this. So that would be the next point. Understand the contradiction here, then question, then explanation.